And then once they have found the value of cos alpha over here, they got a positive value, right? So they got 65.06 degrees for alpha. Hence theta, since this is less than 90 degree, this will be 90 minus alpha. So that leaves us with 24.9 degrees. Now, how to find the angle between two planes? Let the two planes be r dot n1 equals to d1, and then you have r dot n2 is equals to d2. So you have the direction vectors of the normals and you have the scalar constant, right? So over here, cos alpha again, two direction vectors divided by the magnitude of those direction vectors. So this is just like a rule that you can learn, that anytime you have to find an angle, two direction vectors divided by the magnitude of those direction vectors. As simple as that. So here, then the two possible angles of alpha are alpha and 180 degree minus alpha. So if you're asked to find the acute angle, then if you got an acute angle already, then the answer is the alpha that you get. However, if you're asked to find an acute angle and the answer you got is obtuse, then you do 180 minus alpha. So why is that? Why is there two angles like this? So if this, for example, is one plane, the drawing is going to be quite complicated. So let's try to draw it more nicely. Okay. So let's say here is one of your planes, and then here is another one of the plane. So we know that planes intersect at an angle, right? So over here what is happening is that the line at which they're intersecting is somewhere like this. So that is the line at which they're intersecting. So now if we were to find the angle at which they're intersecting, we know that two lines, if they intersect, so this became a ray, but just imagine it to be a line. So if this is a line and if this is another line, so if we know that they intersect at a line, right? So now you can either consider this angle, which will be obtuse, or this angle, which will be acute. A more accurate representation. So this angle acute or this angle obtuse. So when two planes intersect, you have two possible values. You have this acute angle or this obtuse angle. So if you find this angle and they ask you to find the obtuse angle, it will be 180 degree minus alpha. If you find this angle and they ask you to find the acute angle, it will be 180 minus alpha. Okay. But if you find an obtuse angle and they ask you to find the obtuse angle, then simply go with alpha. If they ask you to find an acute angle and they have asked you to find the acute angle, then just go with alpha. Nothing too complicated. So let's try out a sum. So you have 4 points given as alpha as point A, B, C, D. And you are asked to find the acute angle between the plane ABC and ACD. So try out the sum. A little hint is that before you can find the angle between two planes, you obviously need to find the equation of the two planes. We have learned how to find the equation in the last video, so let's get started. Please pause the video and solve the sum. I hope by now you have all been able to solve the sum. If you haven't, no worries at all, because I will be explaining it to you right now. So first what we did over here is we will find the equation of AB and AC so that we can find the equation of the plane ABC. Then you already have AC, you can find AD, and then doing the cross product of AC and AD, you can find the normal of plane ACD. So let's see what they have done. They have found out AB, AC, AD, yes, and then by doing the cross product of AB and AC, they found the normal of the first plane. By doing the cross product of AC and AD, they found the normal of the second plane. The next thing that you need to do is you need to use the scalar product. So over here, you do not need to find the constant, right? Because over here, we're in the formula, as you can see, you only need the direction vectors of the normal. You only need the direction vectors of the normal. So this D1 and D2, which you would have otherwise found by doing the dot product of the normal with any of the points, no need to do it anymore, because we just need the direction vectors of the normal. So since you already have the two normals, simply do the dot product. Then you get the value divided by the magnitude of the normal. So the magnitude for N1 will be root over 5 square plus 10 square plus 5 square. Then this value will be 3 square plus 5 square plus 3 square, right? Because as we know that when we square a value, the minus sign gets erased, so there is no need to take into account the minus values. And hence you have cos alpha, which is a minus value, right? So since cos alpha gives a minus value, the value of alpha will obviously be an obtuse angle. So now if they ask you to find the acute angle, you just need to subtract 180 degree minus alpha, and then you get 5.05 degree. Now, how do we find the point of intersection between two lines? Viewers, please bear with me. We only have a few formulas left, and then we will be done with this, all the formulas of this chapter, and then we will move on to specific questions, and then we will be solving them. So let's get started. So now you have to find the point of intersection of two lines, probably one of the easiest concepts of vector. So simply what we usually do is we equate the equation of the two lines. We have two equations, we have two variables, we solve x and y, right? So since over here we have a third variable z, we need to substitute those two. We need to equate those two too. So we will equate the parametric equations. So as we know, at the point of intersection, the coordinate of this line needs to be equal to the coordinate of this line, right? So at the point of intersection, R1 is equals to R2. So the x of R1 will be the x of R2. The y of R1 will be equal to the y of R2. And similarly, the z of R1 will be equal to the z of R2. So you can form three equations like this. The equations will be like A1 plus TB1. So you know that A and B are constant. The only variable is T, right? Is equals to C1 plus SD1. And then you have another equation, A2 plus TB2 is equals to C2 plus SD2. So solving these two equations, you will get the value of T and S. Now, you substitute this value, as we know that all of the x1 of R1 needs to be equal to the x1 of R2. The y of R1 needs to be equal to y of R2, and then the z also needs to be equal, right? So once you have found the value of T and S, what is the z of R1? It is A3 plus T B3. The only variable we had over here is T. So if you find the value of T, you will get a value. Then what is the z of R2? You have C3 plus S B D3, right? and then substituting the value of s, which was the only variable, you get another value. Now if you see that these two values are equal, they intersect. If you see that these two values are not equal, they do not intersect. Now if these two values are equal, you have found the z coordinate. Similarly, plugging t and s back into any of this, either this or this, you will get the x coordinate. Plugging t in this part will give you the y coordinate, or plugging s into this part will give you the y coordinate. And then you will have the point of intersection, which is your x coordinate, y coordinate, z coordinate. Now, moving on to the line of intersection of two planes. So for the line of intersection, okay, so this was 14. So this, it was our 15 grid. So for the line of intersection of the two planes, we have two methods. Method 1 is by substituting 0 in a variable. So we will learn this using an example. Find the vector equation of the line of intersection of the planes. You have the two planes equation given. So how do you substitute 0 into a variable? So for the intersection of the two planes, obviously for a line, what is a line? We know that we define a line with r is equals to a plus tb, where a is a point on the line, t is just a constant, and then b is the direction vector of the line. So how to find b? So b will obviously be perpendicular to both the line, to both the planes, right? So if this is plane 1, this is plane 2, oh, these are not intersecting. So if this is plane 1 and this is plane 2, the line at which they intersect, it is obviously perpendicular to both the planes. So to find that, you need to do the cross product. And after the cross product, you get the direction vector of b. The next thing that you need to do is you need to find a, which is the position vector of a point on the line. So we are substituting the variable 0 over here. So let x equals to 0. Let x equals to 0 where? Let x equals to 0 in let x equals to 0 in both of these equations. So then you will find two equations with two variables. You will have 3y minus z equals to 1, and then you will have 4y plus z equals to 6. Then simultaneously solving those two equations, you will find the value of y and z, and you had already considered x to be 0, right? So what is the position vector of that point then? The position vector of that point will be 0, 1, 2. And then you have the variable t, and then you have the direction vector that you found here. So then you have 7, minus 3, and minus 2. And that's it. I find this method quite easy. The second method is a bit more complicated. It is where we set a free variable. Okay. So let's get to know what it means. Let the two planes be a1x plus b2y plus c1z. So we have two Cartesian equations, and then we have the second plane with the equation a2x plus b2y plus c2z equals to d2. So what we first do is we eliminate one of the variables using addition or subtraction, or multiplication followed by addition or subtraction. So we can simply do addition or subtraction if the coefficients of one of these So if A1 is equals to plus minus A2, or B1 is equals to plus minus B2, or C1 is equals to plus minus C2, we can just do addition or subtraction to eliminate one of the variables x, y, or z, right? But if none of the magnitudes are equal, what do we do then? We multiply and then we do addition or subtraction. So let's say we have A1 is equals to 2x plus 3y plus 4z is equals to 10. And then we have another equation with 3x plus 7y minus 8z is equals to 10. So over here, what can you do? To eliminate one variable, you can simply multiply this with 3 and this with 2 and then do subtraction and then eliminate x, right? And then you will get an equation in y and z only. Or what is another thing that you could do? You could simply multiply this one with 2. So if you multiply this with 2 and then you added this to equation, z would get crossed out. Z would get crossed out and then you would have another equation in terms of this two variable. So that's what we're doing. We are eliminating one variable with simple algebraic manipulation. Once you've done that, the next thing that you need to do is, in the remaining equation, we set one variable as a free variable. That is, consider it as t. And then we will express the other two variables in terms of t to obtain a set of equations. So what does that mean? A set of equations where x equals to a plus bt, y is equals to c plus dt, and e is equals to ft. So over here, let's say we have eliminated z. Okay? If we have eliminated z, we can go back to our previous equation. And then we can express x in terms of y. And from that equation, we again will have two variables. So we are expressing all the variable in terms of the one free variable, which is t. This will be more clear when you go into the sum, because now it seems like a lot of words without actually understanding the meaning behind it. So let's get straight to the example, and I will draw your attention back into the method to make you understand what each part corresponds to. So, for example, we have this sum over here where by setting y as a free variable, determine the equation of the line of intersection of planes, these two planes. So over here, what they're doing first is they have added the two equations to eliminate z, and then they're left with 5x plus 5y is equals to 15, or x plus y is equals to 3. So now you can say that x is equals to 3 minus y, right? You are expressing x in terms of y. So now you need to substitute this back into the original equations. So you have x is equals to 3 minus y. So if you input this into this equation, you will have an equation in terms of just y and z, right? So then you have z is equals to minus 3 plus 2y. So what you can see over here, that we are setting y as the free variable. So if we let y is equals to t, what we are left with? We are left with x is equals to 3 minus 1t. Y is equals to 0 plus 1t. Because since y is equal to t, it only has the direction vector 1, right? So, for example, x has a value plus the variable t into another coefficient value. So it is 3. So this value over here is 3 plus t and the coefficient is minus 1. What about y? Y is only t, right? So what can we write it as? We can write it as 1 plus t into 1. So in the parametric equation, we have y is equals to 0 plus 1t. We have z is equals to minus 3 plus 2t. And that is the equation of our line. Although this is a bit more complicated, this often comes, sometimes in the question paper it is specified that this is the formula that you have to use. So in that case, you do not have any other option. So I would suggest you to learn this one thoroughly as well. The method is easy once you get used to it. Initially it will seem hard, but with practice it will all be easy. If you need these notes, do let me know in the comment section and I will drop the notes for you and you can access it from there. Now what we need to find is the area of a triangle. So this is actually something that we have done before. So to find the area of a triangle, we have the triangle OAB. So the area will be the direction vector of A cross product the direction vector of B, and then you will find the magnitude of it and you will divide it by 2. Very simple. So let's get started with the sum. Just remember the formula and plug it in. So you have to find the area of the triangle ABC given that the vertices are A, B, C. You know the points. So now first you need to do the cross product, you first need to find the direction vector of any two of the sides. So you can find AB and AC, you can find BC, BA, you can find CB, CA, it does not matter. So they have found over here AB and BC. And then they did the cross product, as you can see. Doing the cross product gives you this value. And so if you plug this back into this formula, so the area will be half into the magnitude of the direction vector that you found using the cross product. And that will be your area. So now if they ask you to find the area of a tetrahedron, what do you think will be the formula? For a tetrahedron, obviously there will be a similar cross product. So what is a tetrahedron? A tetrahedron is basically a pyramid-like shape. I can draw a shape for you. So a tetrahedron has 4 edges, right? So let's say you have this. Tetrahedron used to come a lot in the older papers. It does not come so much recently. But since it is in the course book, you should obviously learn it. Okay. So now this is our tetrahedron. So we already know how to find the area of this triangle, right? So obviously to find the volume of the tetrahedron, you need to build upon that. So over here, as you can see that some part of it will be constant. So you have A into B and then you have the half, but then it is multiplied with 1/3. And why is that? So it is because to multiply it with each of these areas of these faces, to find this faces of these 3 areas of the outer edge, what you do is you do the dot product with C. What is C? It is another one of those direction vectors of the tetrahedron. So for example, over here you have AB, you have AC. So let's say you have a 4th coordinate, then AD will be your C, right? And then you have to divide it all with 3 with the existing half. So it becomes 1 by 6. And then you have the cross product from the area of the triangle, because the area of the triangle is now being multiplied with each of these 3 faces. And then to account for the loss in volume from the upper edges, you have to divide it with 3. Not too important, we can jump straight to the formula and go do the sums. So you have the volume of tetrahedron. So find the volume of the tetrahedron where OA, BC. So you have 4 of the points over here. They could have given you 4 points or 3 equations of lines. So they have actually made it a lot easier for us by giving us the equation of the lines. So we need to find the cross product of any 2 direction vectors to get a normal. So they did with OA and OB to get the value of the direction vector, which we need to do the dot product with the direction vector of OC. And then the resultant magnitude is divided with 6 to find the volume. And that was our 16th formula. And with that, we end this chapter. There are some nuances that cannot be covered in just formulas. Sums that you need to do using these formulas, but they build upon some more conceptions. So I would suggest you guys go over these 4 videos again and again, get all these formulas acquainted with, memorize so that you never forget them, and then we can go into their further applications, because sometimes the sums are just not as easy as asking you to find just the intersection or the angle, though most of the times it is, but we want to be prepared for everything. Thank you everyone. Best of luck.